Okay, we're up. So let's see, we're up to a Wednesday. So the big thing in our schedule is for Friday is to have the first test. So again, if you're in the large section, that's the live class section, show up on Friday. I'm going to be out Friday again. I've kind of been doing that all semester. So the TAs are going to actually come with the exams. And in case you don't know who they are, if I can zoom in here, Ani and John. And they are, on our Canvas page, so you can, get at them that way. They got their emails here. I did have it happen one time where I think I was actually in Korea, and my TA forgot to come and hand out the exam. So whatever happens, it's all going to be good, right? We're going to recover. I doubt if that'll happen for Friday. What happened there was I was gone for about 10 days, so I gave him the exam about 8 days ahead of time, and then he forgot. So I don't expect that'll happen. We do have the storm coming, so that if UF, sometimes just out of caution, they'll go ahead and close campus, and if they do, we're just going to shift everything to Monday and just do it then. So whatever happens will be success. It'll be good. Okay, but now, even though the exam focuses on materials chapters 2 and 3, we're way out in chapter 6. And where we're headed is for the reverse analysis. What we're looking at is take our 6 degree of freedom robot. You're given the desired position orientation of the last coordinate system. And we made a couple free choices so we can see in that 7 line, we closed the loop and calculated all the parameters associated with that hypothetical link. And what we did is we turned our 6 degree of freedom robot into a 1 degree of freedom closed loop mechanism where, for example, we knew theta 7. So if you have a 1 degree of freedom device and you know that one input, boom, you're going to be able to solve it. So our focus now is on those closed loop mechanisms. And we're going to generate a whole ton of equations, and I call it the toolbox. Once we have the toolbox, then we're going to take our particular problem, and hopefully we can go in the toolbox and maybe find one equation, one unknown. That would be ideal, things like that. But that's what's going to be happening for us. So to get there, though, we kind of did this exercise last class where we said, let's take our 3D spatial mechanism, bring all the S vectors and A vectors over parallel, and then we inserted those little pieces of metal. We made an equivalent spherical mechanism. And then we just said, for the heck of it, let's go ahead and do a little exercise where we're going to get all the S vectors and all the A vectors, and we are going to evaluate those in the first coordinate system because it's going to help us later on, although we have no idea why we're doing it right now. So that's what we did last time. So to kind of get us back up to speed, we started off with, S1 in the first. Well, the first coordinate system, S1 is along the z-axis, so that was easy. To get S2 in the first, we used this matrix, so I put R2 to 1 back up there. So if I take R2 to 1, S2 in the second, and then it turned out to be the last column. Let's see, is there a minus sign there? I wrote that in the board before class, and I did not write it clean enough that I could even read my writing. So that one was pretty easy. When you do the row by column, you get the last column. And again, S12, C12 are the sines and cosines of alpha 1, 2, and then S2 and C2 were the sines and cosines of theta 2. And then when we went for S3 in the first, we said, well, what if I take S3 in the second? How can I get S3 in the second? I could do that, or to save time, I could add 1 to all these indices, which is what we did. And then when we did, adding 1 to those indices, and we did row by column, we got these combinations, like the top element was a sine times a sine, and the negative one, the next one, middle element was negative SC plus CSC. The last the last element after the last row by column was CC minus SSC, and we gave those names. So we had to know what those definitions were, and let's go ahead and write those definitions down just for a reminder again. SS, Y2 bar, the pattern was negative SC plus CSC, and the Z term, and I'm going to put 3 marks here because it's the definition, CC minus SSC. And then in my head, I had this picture where I saw S2, and then I saw the spherical link alpha 1, 2, and I saw the spherical link alpha 2, 3. So with that picture in my head and with the pattern memorized, I said, oh, theta 2 is at the end. I saw a bar on top, so I was going downhill. So before I get to the S2 vector, I get to the alpha 2, 3 link. So alpha 2, 3 link wants to be near its friend. And then after I pass by, I get to 1, 2. And there was no scientific, thing behind that. It was just a way that in 1979 I had to memorize it, and that's what I came up with in order to be able to remember those. So saved a lot of chalk, because it is, again, the components of this vector in the first coordinate system is a bunch of products of sines and cosines of alphas and thetas, and that's what they are. When we looked at this, though, we said, I could do it symbolically, but if I took that definition and this definition and squared them, I am going to get 1, because I know this is a unit vector, so I knew that was going to have to hold true. But if we did it symbolically, it would. And then the other thing, when we talked about, that was fine for x2 bar, but what if I had x2 without a bar? What if I had x3? What are all those definitions? And the one thing we noticed was, for example, z2 bar equal to z2, because of the symmetry on the definitions of those terms. So, okay, we did that. Then we went one more. We said, what if I get S4 in the first? So we said, if I can get S4 in the second, which the easiest way would be to add 1 to all these indices, or I could go do it by hand, and that's what would come out. So when I substituted S4 in the second, it's x3 bar, y3 bar, z3 bar. Then when we did, again, this row by column, we got these combinations that Dr. Duffy introduced this notation where we had those terms, and let's write down what those definitions are. So this is still kind of review from last time because it's so funky getting this notation thrown at you. So I would remember the pattern, xc minus ys, and then here's the parentheses where I had in excess, xs plus yc. Oh, if I have a cosine, the sign's not as good. It gets the negative sign. And then down here I had a sine, and then the same thing, xs plus yc plus a cosine z. And then it was a matter of, okay, you gave these as definitions, but what are all these terms over here? So I looked at the 3, 2, and I noticed we were going downhill, and I've got a double subscript, so these are going to be single subscripts. Single subscripts sometimes have bars on top to indicate they're going downhill, and that is what's going to happen. x3, c2, y3 bar, s2. 3, 2, 3, 2, 3. And then the way I remembered this last term, I looked at all the definitions were in there, and they were all the sine and cosine of some one of the alphas. And the way I remembered it was I took the next number, 1, and I said I don't have an alpha 1, 2, 1, but I do have an alpha 1, 2. Where, what's x3 bar? Well, I could rewrite it, but it would be what, s3, 4, s3, the same definitions. So all these definitions kind of seemed overwhelming and all. A couple of comments, though, that I didn't make. So I was peeking through the book today. This term in here is going to appear by itself sometimes, so we're going to give that a name. Like, it did not appear in S4 in the first, but we're going to call that x32 star. That's the xs plus yc part. So x32 star would be x3, y3 bar. So I forgot to mention that last time. And the other one I forgot to mention was, what if I was to take this definition, x32, and square it, and then take this definition and square it and square it? It's going to come out to be 1. And I'm going to show that I have a maple file that I can show that that happens. And the other thing, we're going to show it in the maple file, but remember how Z3 or Z2 bar and Z2, by definition, it was really obvious to tell that they were identical. Well, if I take Z32's definition, which is on the board over there, and I take Z23's definition, and I expand it all out, they are going to be identical. I don't feel like doing that, but I let Maple do it, and we're going to take a look at the Maple right now. So I just made a PDF of this Maple file. It's supposed to show those two things. Okay. Good. Okay, so I come into Maple, And I always like to give it a restart, and in case I need any of the linear algebra stuff like multiply matrices, we got that. And there's no magic here. I guess what I'm trying to show is that if I square that and square that and square that, I'm going to get identically 1. So what did I tell Maple to do? Well, I let Maple do what it's good at, symbolic operations. So here's, I'm using x3 capital B for the bar. So there's my definition for x32, y3. And then I just jammed it into this thing, A1. I said, hey, go ahead and sum those squares. Okay. And I said, well, go ahead and expand it. So it got rid of all the parentheses squared. And I get all this junk. And you say, how am I going to show that that equals 1? Well, hey, I need to substitute, right, x3 bar, y3 bar, z3 bar. So there's those definitions. And now that those are in there, expand it. Holy cow, right? Maple doesn't care. But, so imagine if we didn't have the notation, right, and I'm writing, these definitions out, they'd be, these terms, they'd be gigantic. Okay, then I said, Maple at this point does not know, for example, that C12 is actually the cosine of alpha 12, so it doesn't know about the trig identities. So I did a substitution. I just said, everywhere you see S2, put the sine of theta 2. And everywhere you see C2, put that. Everywhere you see that, put that. Everywhere you see that. The same with all the alphas. So I set up all those substitutions. Now with those substitutions, I call the new thing A4. So here it is with all the sines and cosines. And then I just said, hey, simplify it. A lot of times you have to simplify A4, maybe comma trig or something to tell it to use trig identities. But I didn't even have to do that. It just came back and said, and I believed it. I didn't regroup everything, right? But Maple's pretty good. Sometimes Maple won't notice the reductions, but on that one, it was holy cow. So that's kind of like by brute force. We just showed that if you sum x32's definition squared and y32's z square them and add them, yeah, they do go to 1. Now the next one I wanted to show was that I've got z32, right, was defined up here. Let me get rid of all the ink here. But we got z32. And I wanted to show that it equals z23 by definition because it's too hard to do it by hand. So I came down and I said, okay, I'm going to go ahead now and define z23. Wait a second. Here it is, right? It's an s times xs plus yc plus a cosine z. And I have to define x2, y2, z2, so there they are. So now when I printed z23, here's what we got. And then I went ahead and I printed, that's what we had done previously, that was z32. And I said, let's take this and subtract that. And I got this, and then I said, okay, expand it or do all the math, and yeah, it came out to 0, so they were the same. So I let Maple do the brute force hard work. And again, so I forgot to mention about for the multi-subscripts, how they will square and add to 1. There might be some time in the future that'll come in handy. And also the z32 equals z23. Then we went for the next one, S5 in the first. So we could take S5 in the second and bring it back through 2 to 1. S5 in the second was x43, y43, and we did a whole pattern and we came out with some new definitions, x432, y432. Again, x432 star is going to be the part in parentheses, xs plus yc. So it would be 432 in case we ever see that combo. It didn't show up here, but it's going to show up later. Also, we could show, well, I can tell that this squared plus that squared has to go to 1, right, because it's a unit vector. But also, if we were to do what we just did with z23 and z32, if I took z234's definition and expanded it all out, it would be the same. There is a symmetry there on the z's. And then lastly, we did S6. And what did we get? I feel like I'm missing a term here. No, 32, 432. No, I guess we're okay. 5432. And again, if I sum the squares of those definitions, they're going to go to 1. If I expand Z2345, it's going to be the same as Z5432, all that kind of stuff. And it seemed, a little bit overwhelming with the notation, but you saw in that Maple thing, if we go to the bottom line here again, You know, like Z23 is not that complicated a thing, but without the notation, holy cow. You know, these would, imagine what the S6 in the first, those three things would be gigantic and messy and everything else. Okay, so that's kind of what we did last time, and you know, it's not always exciting to go through the review stuff again, but it is going to be important for us to be able to use this notation when we start generating equations. And this is one way to introduce the notation. So what we've got left to do is to take all the A vectors, A12, A23, we want to bring those all back to the first. So I'm going to erase this board. So we're going to start with the A vectors. And I'm going to reuse this part here, but I'm going to leave R2 to 1 there. Okay. Oh, well, the x-axis, right? No big deal. X-axis is along there. Let's see. What's going to be the easiest here? Let's see. I'm going to rewrite R2 to 1 down here. And again, this isn't like, there's a couple of lectures where like coming up as some of my favorites. Yeah, this one's not my favorite, but it's a necessary evil to go through this notation because it is going to pay off big time. And I'm hoping the coffee's going to kick in a little more here. Okay, so we're going to take, let's see, A23 in the second. Okay, A23 in the second is 1, 0, 0. Remember the second coordinate system, the x is along A23, and you know, the z is along S3. Okay, so, oh, it's going to be the first column. Right, when I do row by column, right, I'm going to get that first column. So A23 in the first was no big deal. No new notation yet. Okay, so then we're going to go for the next one, A34 in the first. Okay, this one's going to take another sip of coffee to get through this one. Okay. Okay, to get A34 in the second, I could take A34 in the third and do R3 to 2, and or I can add 1 to all these indices. So that's what I'm going to do to get A34 in the second. We are going to go ahead and put C3, S3, C23, S3, S23. And again, it's brute force. We're just going to do row by column. So it's like, holy cow, and I do the first one, I get, let's see. I'm trying to think of which way do I want to write it. Well, I got a 50-50 chance getting this right. C2, C3 minus S2, S3, C23. Okay. Row by column, so there's no magic there. The middle row by column, I see this C12 over, no. Do I want to pull that out? I mean, I see that C12, it's really tempting to pull that out. Oh, I guess we will. I'll pull it out. C12, and then I'm going to have S2, C3. And then I'm going to have C2, yep. C2, S3, this is where I need maple this morning, so I didn't make any mistakes. But oh, and I'm not done yet. I got another term over here, so I'm like, great, and I'm out of board space. Minus S12, S23, S3. So that was that last boom, boom, which I messed up. So I'm going to give a little more room here. I'm going to pull the S12 out front. And again, row by column, I'm going to have SC, plus CSC plus C12 S23 S3. And you say, well, whoopee, right? I mean, this is torture today, right? It's just that was just brute force. And again, it's an awful lot of chalk if I write that up there. So you might think that Dr. Duffy looked at those and I'm going to call this something, 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 but he didn't. He said, you know what, I'm going to introduce this notation that's similar to the XYZ notation, and then I'm going to see where that notation might plug in over here. So, for example, when I look at this top term here, CC minus SSC, remember when we did our Z definitions, we had that same pattern. Except in the Z definitions, these guys were alphas, and now they're thetas. And in the Z definition, that was the theta, and now it's like, holy cow. So we're just going to go off to the side, and we're going to come up with a notation that is, and then we're going to see how that notation can simplify that expression. Hopefully I didn't make any mistakes there. So we start off with, in effect in this notation, the alphas and the thetas are going to be switching places. So he came up, instead of X, Y, Z, he came up with, he called them U, V, and W. And there's no single subscript terms because, right, the alphas have two numbers, right? The thetas had one number, that's why he had seen. So let's see, which one do I want to define here? Let's see. I think I'm debating to define 2-3 or 3-2. I'm going to peek in the book to make sure I do the one that's going to plug in the easiest for us here. So let me take a look. I think it's going to be 2-3. Oh, it's 3-2. Wait. Oh, okay, it is 3-2, the one we're going to want to define. So we did our multiplication over there, and we got the, what that vector was, A3, 4 in the first, and it's real messy. And now we're just going to go off to the side and come up with some notation, see how that notation plugs in. So this is what Dr. Duffy came up with. He said, I'm going to use the same exact patterns that we had with the XYZ notation. SS, negative SC plus CSC, CC minus SSC. Okay, the thetas and the alphas are switching places. So remember how in the XYZ we had the theta at the end? Well, we're going to have an alpha at the end. And the alpha I'm going to use is right here. I don't have an alpha 3-2, so I'm just going to put 2-3. And again, when I was memorizing this crazy notation, so it does seem nuts. We're doing this notation, but it is going to pay off big time in the future. And again, it was closed book. I had to memorize it. And I said, wow, these that were alphas in the XYZ notation are now going to be thetas. And I said, oh, 3-2. Well, 3 came first. It wants to be near its friend. So I'm using the same silly things from 1979 that I had to come up to memorize it. And then 2 is what's left. You say, okay. If you want to make that definition, nobody can say you're wrong. Say, okay. So let's see how those definitions are going to help us over here. I look at this top one. Holy cow, that's W32. So I gotta pay off there. But it's not like when we did it last time where he said, whatever that is, I'm going to call that X something. No, we're going to use that notation that's very similar to the XYZ stuff and see how it magically appears. So I'm going to look in here and say, wow, that is negative V32. And here it is again. And then we look over here. That is U32. So I'm really glad that he went this way, that he didn't just say, oh, these are the new definitions, I'd have all these new patterns and everything. No, he came up with this UVW, so it was very similar to the XYZ notation. and then saw that it appeared. But then he said, well, let me even go further. Let's go ahead and define U321. So we're going to go with more multiple subscripts. And he said, you know, when I define these terms, I'm going to use the same pattern that we had for the XYZ multi-subscripts. So we had an X, we had XC minus YS. So here it's going to be UC minus VS. For the Y, we had a cosine in XS minus a sine Z. So I'm going to have a cosine. Well, I don't have XS, but I got, this is in my head I'm going XS plus YC minus a sine. In my head I'm going Z, no, but it's a W now. And then for this last one, it's the same kind of pattern. U XS plus YC, but no, it's US plus VC now, plus a cosine W. And again, right now we're not worried about how does this match up with what we had on the board over there. We're just saying we're going to make these definitions. And at least the patterns are the same, so I could handle it. Now it's just a matter of how do we fill it out. So remember how these were thetas last time? Well, they're going to be alphas now. They're going to be, I take the last two numbers, 1, 2. And let's see, this here is going to be 3, 2, 3, 2, 3, 2, 3, 2, 3, 2. That's pretty similar to what we had. And then last time, these were alphas, and they all had the one, well, and remember how I had to take the next number? Well, I don't have to take the next number now. I can just put the ones if I haven't messed this up. So I came up with a way to remember that, and I hope I didn't mess that up. Okay. Remember when we introduced the X star notation? It was the part that was in parentheses. We're going to introduce a U star notation. I'm going to introduce that one. It's going to be what's in parentheses here. And then, if I have any luck today, we're going to see how some of these terms that we just defined are going to actually plug in over on the other board there. So, not going to get much simpler on this top term, right? It was W32's definition, so boom, we're going to keep that. But look at this. I've got a negative and a negative, right? I could pull that all out front and make them positives. U32S2 plus V32C12. Wow, this whole line here became negative U321 star. Because on the other board, we just defined those terms. And again, the U321 star was the part here from the, the NXS part. And when I looked over here, I happened to have that. And then this one, I got a cosine U minus a sine V. Holy cow, it was right there. So he introduced the UVW with the same patterns he had for XYZ. So again, I'm going back to flashbacks, and their flashbacks where this cold thing goes down your spine because it was scary back then because it was closed book. And it's not closed book now. But, okay, if you use those definitions, boom, here's what came out of that. So I'm going to erase that. And I'm going to go up here and say we had W32, we had negative U321 star, and we had U321. Didn't have to use much chalk. I did need more brain power to remember what those definitions were, but yeah, okay. And again, we don't know why we're doing this, right? But it's okay. We're doing it to introduce this notation because it's going to pay off later on. So that was kind of funky. And we're going to keep going. Right? We got to go all the way up to, what, A67 or somebody like that. So let's do another one. A45 in the first. So we said, oh my goodness, it's going to get messy, but let's see what happens. If I take A45 in the second, I'll get an R2 to 1 it, I'll get 4-5 in the first. Here's R2 to 1. Am I going to get A45 in the second? I'm going to add 1 to all these indices because I don't feel like going through what we just went through to generate it, but that's what I will get. I'll have W432, negative U star 432, and U432. And again, there's no magic here. We're going to go ahead and just, to get A45 in the first, just row by column. So I'm going to take this times that, and the negative gives me a positive. S2 U432 star plus a cosine W432. Did I do this right? Wait a second. No, I had a mistake here because I said, yeah, there's not supposed to be a 2 there. 4-3, okay. Oh, but there is a 2 there. I knew something was wrong here. There's only 4-3, okay. Next one, row by column. I'm going to take this term times that term, minus S12 U432. And then I'm like, holy cow, look at all this junk, right? I got this times that and this times that. I can pull the C12. I'm going to write it underneath here, pull that out front. I'm going to do this term first. Minus, holy cow, U432 star. Right now I'm pausing because there's like I'm over 50% chance that I'm going to drop a minus sign or do something stupid here. So be ready. All I'm doing is trying to do row by column. So that, oh, I missed a C12, or what did I do? Yeah, there would be a C12 in here. Okay, and then I got that. Oh no, I pulled the C12 out. Here we go. S2W43. Okay, so that was the middle term. And then the bottom term, it's like, oh my goodness, I'll take this last one, C12, U432, and then I'm going to pull the S12 out, and I'm going to get C2 with a minus sign U432 star. Something's fishy again, because I should not have a 2 and a 2. Oh, no, I'm okay, I believe. Okay, what's left? Oh, S2, W43. So that's the bottom term. And it's like, oh my goodness, this is just getting out of control. So we defined, this is the equivalent to the XYZ single subscript, you know that, and then here's the double subscript equivalent. And we're going to write now the equivalent triple subscript terms. I just don't have any board space, so I'm going to erase the top and put it up here. And we are going to write, who are we going to write? Oh. U432, I think I'm going to, yep, write these. And we also need the U star term. So let's go ahead and make these definitions. It's kind of equivalent to the XYZ when we had single subscript and then double and then triple. This is equivalent to the triple subscript, and they're the same patterns. XC minus YS, UC minus VS. A cosine XS plus YC minus a sine Z. And just every time I say X, I'm writing U, and Y, I'm writing W, or V, I'm sorry, in the W. And here's the pattern. And then this guy is going to be what's in the parentheses. And let's see if we can fill them out here. So I know that These were sines of thetas, sines and cosines, so they are going to be alphas now, so it's going to be the last two. Okay. And for these guys, it's going to be 4, 3, 2. It's not quite as obvious how they split up, but this came from memorizing them. And again, when you do definitions, nobody can say you're wrong because you just made it up. And then there's one term left that used to be an alpha. Oh, and I better get these guys. There's one term left that used to be an alpha. It's going to be a theta. It's going to be the last one. Okay, so if we had those definitions, and I wish this guy was not crowding because that's a special one. We're going to see, do those definitions kind of appear over here. So I look at this top one, S2U432 plus C2W, where is that one appearing? I don't have that one on the board yet. Okay, what would W432's definition be? It would be, according to the pattern we have here, S, XS plus YC plus a cosine Z, and it would be, what, a 2, this better match up. Yep, 2, 3, 2, 3, 4, 3, 4, 3, 4, 3, and a 2. So that one wasn't on the board yet, but if I did take that expression, and then I said, that's got that's a U star term, right? That would be U star 432. And then I look at what we did get over here on the top. S2 times U star. Holy cow. So this term, based on this notation we came up with, is W432. I just have to remember how to, what that expansion is, what that definition is, and it is open book, and I know the pattern, but I got to remember how to fill in all the, but yeah, that's what happened. That's what came out of it. And then we look at these next ones and we say, wow, what have I got in parentheses here? I've got a negative cosine times a U star plus an S2W43. This thing in parentheses it looks like a cosine, stuff in parentheses, plus a sine. I keep going Z in my head, right? That looks like the negative of what was a Y term, so that would be a V term. What's in parentheses there is the definition of negative V432. So if I was to, basically if I added 1 to all the indices, I've got the definition of 321 over here. If I was to add 1 to all those indices, I would say, oh yeah, what's in parentheses was the U star 432, and then, wow, it's times the C2 and the, holy cow, it is. And then I look at this and I've got a negative XS, negative YC. That whole thing is negative U4321 star. Holy cow. And then we go to this crazy mess down here, and we look at what's in parentheses, and this is a negative V432. And then I've got a UC plus, oh no, with a minus a VS. Cow. If I did that right, 432. I hope I did that right. So what Dr. Duffy did when he got to these A vectors is, there's nothing we can do. We just brute force multiply these matrices out and we get these combinations. But instead of just saying whatever came out, I'm going to make that some definition, and whatever came out, he came up with this notation with UVW that was very similar to the XYZ, and then saw how that notation got utilized. And again, this is not fun, right? And you're like, oh, let's, and then we got the test, and then we're going to actually start doing stuff with it once we get out of this part of it. So this is like a necessary evil. to get to where we want to go. It's a necessary evil so that on reverse analysis stuff, you guys are going to be some of the best in the world at doing this. And you're going to know a lot more than people that come out of other classes. Okay, so with that, like I don't feel like doing the other ones, let's jump to this. Let's see if I got them right here. So I'm checking. We did that one. Here I had a 432. Oh yeah, I got that one right. And if we were to do similarly, you would get these expressions to come out. So for whatever strange reason we wanted to do this, right, to get all the vectors in the first coordinate system, I can write them down on this piece of paper here without using too much ink and without making any mistakes. Right? If we didn't have the notation, imagine expand that all the way out where all you saw was the sines and cosines of alphas and thetas. Holy cow, right? It would just be a giant mess. And then you saw what we did today where Maple didn't care that, you know, they were gigantic and they could handle it and all. So that's is what we, suppose I wanted all the vectors in the second coordinate system. I forgot if I have to add or subtract. I guess I shouldn't have said that today. In other words, I'm either going to add or subtract one off of all these indices and get that to all work out. So that was our goal, was to get here and say, well, where are we going to go next with this? And actually, I'm looking at the clock. We got 9 minutes left, and it's a good, painful place to stop today. But let's see what's coming up next. So as we go through the book, we're doing just what we did in class. Right, here's R2 to 1, this is A34 in the second, that's what came out, and then we said, oh, let's go off to the side and come up with this notation for U's, V's, W's, and then here it is with just I's and J's, and then here's the notation if, like U, Ji versus Uij, there's the difference. Oh, the W's, though, are identical. Here's the stars, and when you applied all that, you know, we got that result, and then it showed the notation again where there were more terms, and I want to get down to that table, A67, there we go, so we got down to there. So what's coming up next is we're going to go ahead and start applying this. We're going to go ahead and look at this, the first closed loop mechanism is going to be a spherical triangle. So our problem statement is going to be, imagine that, well, first of all, let's look at the mobility. What if one of these links is fixed to ground? So I should have drawn little marks there. If that link was fixed to ground, and again, these other links are on the sphere, you look at the mobility, and the mobility equation was 3 times n minus 1 minus the sum of the, 3 minus how many, and it reduces because the number of joints equals the number of links. It reduced to the sum of the freedoms of the joints minus 3. Each of these joints had 1 freedom, 3 joints, 3 minus 0. So it's a structure. So this thing's not going to move. So in the problem statement, and if I give you those 3 alphas, right, that's going to be the angles on those links, we should be able to solve for theta 1, theta 2, and theta 3. So we're actually going to go ahead and start trying to solve some problems. And it's going to utilize the stuff that we did today to get there. We're going to build up this toolbox. And then after we do that one, we're going to come in and go to, oh, here's a numerical example. If I went to the shop and made those 3 links, what's theta 1, theta 2, theta 3, so that you could assemble it. Then, just to sort of set us up, we are going to go to something else extra. But we're going to go to this 4-bar. So if one link is fixed to ground, and the problem statement then is if I give you all 4 alphas, so those are like your link lengths. If you look at the mobility of this, it's a 1 degree of freedom, right? Sum of the freedoms minus 3 is 4 minus 3 is 1. So we're going to give you 1 theta. So suppose I give you theta 4. We want to calculate these other ones. We're going to do that. And then we're going to look at a 5-bar and a 6-bar and a 7-bar and look at those kinds of problems. And to get there, though, we're going to generate sets of equations and put them in our toolbox. And then when we get a problem like this, we say, what are we given? What are we looking for? Maybe I can go in the toolbox. It'd be great if I could find a 1 equation, 1 unknown, right, and start solving the problem that way. So be patient with us. It is awkward because, again, you're probably worried about Chapter 2 stuff because of the exam, and here we are doing X, Y, Z, U, V, W, and we did the U, V, W pretty fast today. But it really came in handy for whatever reason to get all these vectors in that first coordinate system. Boy, we have a nice compact way. So you had a question? Yeah.
It's unrelated to
Yeah.
for the exam, will the solutions for homework 3 be posted?
Oh, the solutions for homework 3 was the question. Yeah, they should have been by now. It's when I walk back to the office, I should tie a string around my finger or something. So if you don't see them up there in an hour, then send me a text or something. But yep. So we'll get that set up. And again, for Friday, the TAs are going to have the exams. They're going to pass it on. The people that are online, I'm going to be in Alabama, but I will at the same time send it out on Canvas. But if they do decide to close campus for Friday, I don't think Gainesville's going to get hit much, but just out of caution, sometimes they'll do that. And if that's the case, we'll just slide everything to Monday and have a good weekend, things like that. Okay, see you next time.